Talking about periodic waves, a periodic wave is a wave that repeats itself at regular intervals. It can be either sinusoidal or complex. Because the wave repeats itself periodically over time, it is characterized as a periodic time function. Which of these waves are periodic? The sine wave is periodic. A. You see how it repeats itself? C and D are also periodic because we can say that all of the features within one cycle of vibration are duplicated almost exactly in the next cycle. So you see how C and D both repeat themselves? That means the wave is periodic. There are two kinds of periodic waves. They're sinusoidal, which result from simple harmonic motion. All sinusoidal waves are periodic, the simple sine wave. Complex waves can be periodic. They don't have to be periodic, and they are not sinusoidal. Remember, complex waves are a bunch of sinusoidal waves added together. So if we go back to Fourier's theorem, any complex periodic wave consists of some number of simple sinusoids that are summed together. But to be complex and periodic, there must be a mathematical relationship between the sine waves. So to be a complex periodic wave, there is a mathematical relationship between the pure tone sine waves that are added together. And that's called a harmonic relation. The frequencies of all the sinusoids that compose the series must be integer or whole number multiples of the lowest frequency component of the series. So there's a mathematical relationship to complex periodic waves. The example we're going to use is to create a sawtooth wave. So the lowest frequency of a sinusoid, this is an example, is 100 hertz. That's the fundamental frequency. The most powerful, important frequency is 100 hertz. The other sinusoids that compose the complex wave, therefore, have to be 200, 300, 400, 500 hertz, etc. The next example for the sawtooth wave, let's say the lowest frequency is 110 hertz. The other components must be 220, 330, 440, 550, etc. So what you do is you take the fundamental frequency and you times it, you multiply it by whole integer multiples. So 100 times 1, that's our fundamental. 100 times 2, 200. 100 times 3, 300. 100 times 4. Or in the example of the 110 hertz wave, 110 times 2, 110 times 3, 110 times 4. And these are all the sine waves in the harmonic series that add to create the complex wave. So when a harmonic relationship exists among the frequency components, you have a series of frequencies, a harmonic series, and all the sinusoids in the series are called the harmonics. The first harmonic is that fundamental frequency, then you have your second harmonic and your third harmonic and so on. This is the example that I gave before. The first harmonic, or the fundamental frequency, is 100 hertz. So 100 times 2, your second harmonic is 200 hertz. 100 times 3, your third harmonic is 300 hertz. This only works for the example of a complex sawtooth wave. And here's a complex sawtooth wave. You see how it's periodic, it repeats itself at regular intervals. And that's because there's a harmonic relationship between the sine waves that were added to create the complex wave. And the sawtooth wave resembles the waveform of the sounds that are produced by our vibrating vocal folds. We're going to do another example with a wave that has a fundamental frequency of 125 Hertz. And all the components, or the harmonics, are odd and even whole number multiples of that fundamental. So what are we going to do? We're going to take 125 times 1, right? That's our fundamental. 125 times 2, 125 times 3, 125 times 4, and so on. And here are our harmonics: 250 Hertz, 375 Hertz, 500 Hertz, 625 Hertz, and they get added together to create the sawtooth wave. So to be complex, you have a lot of sinusoids added together, but to be periodic, you must have a harmonic relationship. There must be a mathematical relationship between the simple sine waves that are added together.